Good evening. I'm Ali Moore, one of the directors of Cheltenham Festivals, and a huge welcome to you all to the Famelab International Final 2018. Whether you're here in the arena in the UK or whether you're watching around the world through our live stream, it is wonderful to have you with us. The film that you've just seen, that's the first time it's been shown. It's the premiere, and we've made it with the British Council to spread the word about Famelab even more around the world. Famelab is one of the jewels in the crown of the Cheltenham Science Festival. It is incredible in so many ways, not least because what a wonderful way of bringing people together from around the world. Here this week we've got the national finalists from 27 countries around the world who are united through their passion for science and their passion for sharing it with the world. And we are really delighted with the British Council to be able to facilitate that. As I'm sure many of you know, Cheltenham Festivals is a charity. It produces 4 festivals around the year, but it also has a year-round education programme. We work with 25,000 young people, and we have a specific focus on making the sciences and arts accessible to those from disadvantaged communities. Another specific focus of ours is talent development, and that's where Famelab fits in for the Science Festival. We want to be able to discover and to develop the next musician of the future, the next writer of the future, and the next science communicator of the future. And that's why we created Famelab all those years ago. That's also why we partnered with the British Council to enable us to take what we had as a UK competition worldwide. So thank you to the British Council, particularly to Adrian Fenton. Yes, let's have a clap for the British Council. Particularly to Adrian Fenton and Stephanie Renworth, who are here today, and Ben Austin. So thank you to the British Council colleagues from around the world who are here, and it is an absolute pleasure to be working with you. I am delighted to be able to introduce the most phenomenal science communicator and a consummate host. Please, can you join with me in welcoming Quentin Cooper to the stage?
I am a scientist. I am a scientist.
Thank you very much indeed. Well, that video is great. It's done most of my work for me. I just need to say that's it. Off we go. So welcome, one and all, whether you're from Walsall, Montreal, Nepal, Senegal, or just from Cheltenham, to the grand final of Famelab International 2018. So first of all, welcome to our highly excitable audience here in Cheltenham. Very good. And also to our audience watching round the world. So give us a cheer whether you're far or near. No, that was for the audience right now. Obviously, we can't hear them, but it's all about inclusivity these days, so you've got to do these things. Now, as one or two of you will be aware, even at a science festival, exactly 1 week today, the World Cup finals start. Massive global event. Took over 50 years before they got to 24+ participating nations. Famelab, under 10. Right? So the finals this year, we've got 27 participating nations, so there is no doubting which is the bigger competition, providing you look at the data extremely selectively. Also, if you pick and mix a little bit with your facts, no debating which is the more truly global. You look at the World Cup, almost 3/4 of the teams are from Europe or the Americas. But for yesterday's 3 tremi-finals that we had here in Cheltenham, we had the national winners from Australia, Bangladesh, Brazil, Bulgaria, Cyprus, the Czech Republic, Egypt, France, Germany, Greece, Hungary, Ireland, Italy, Kazakhstan, Korea, Malaysia, Malta, the Netherlands, Portugal, Poland, Qatar, Romania, South Africa, Spain, Switzerland, Thailand, the UK. Oh, I can do that in all one breath, in strict alphabetical order. So that's far more global. It's also clear which is the most competitive competition because, unlike the World Cup finals, every country taking part has a decent chance of winning. Well, they did until yesterday. Obviously, some of them have now been eliminated. Also, no doubt, which is the most open and fair. Whereas there have been all sorts of scandals at FIFA in recent years, this FIFA, the Famelab International Final Awards, is completely untainted and almost sainted. And finally, it is also the most youth-oriented because whereas in the World Cup this year, 2018, the youngest players taking part are 19, there's only a couple of them, Famelab has an entire version, Famelab Academy, only open to 13 and 14-year-olds. And with us tonight, I'm delighted to say we should have the 2018 winner from Pates Grammar School here in Cheltenham, Hugh Barlow-Kay. Hugh, if you can get the lights up and you can stand up and take a bow because you've richly earned it. There he is. Congratulations. Thank you, Hugh. So, by now you'll have reached the inescapable logical conclusion that you have somehow got tickets for something that is even bigger than the World Cup final. However, if you've not been to Famelab before, you may be a bit vague about what's actually in store. Who's an absolute first-timer here and is not really sure what they're in for? Oh, it's a decent bunch of you. Thank you. You're particularly welcome. Okay, well, essentially, you are in for some distilled brilliance, right? Yesterday, having won their way through heats and finals and national championships, the 27 national winners duked it out here in Cheltenham in 3 tremi-finals to get to 12 people who are with us today. 3 from each tremi-final sent through the judges and 1 sent through by the audience. So it's those 12 winners you're about to see, and we're going to have an audience vote as well today. So I'll give you to explain how you vote later, but the one thing I need to tell you right at the start is if you like somebody and think they're best, keep a mental note. There will be no chance to see them a second time before you vote. There's no refresher video or anything like that. So as you're going through, after 12, I know it can get a little bit blurry, but try and do it. Now, the other thing to know is, right, the rules of engagement. They are disarmingly simple. Each finalist has 3 minutes to clearly and charismatically convey something of the magnificence and significance of science, the resonance and relevance, the importance and refulgence, look it up, the beauty and the booty, the wow and the how. You get the idea. No PowerPoint, no props unless they bring them on themselves, no safety net, and no clipboard like what I've got. Okay? Then they have just a couple of minutes to wrestle with whatever pertinent or impertinent questions our 3 judges will throw at them. And who are these 3 judges I anticipate you asking in the very near future? Oh, yeah, that's good, fine. It's all uncanny. If this weren't a science festival, you'd think I was psychic. So please can we welcome first, Professor in the Physics and Astronomy Department at the University of Southern California, broad spectrum science communicator with a particular fondness for interacting with artists of all kinds, author of new graphic non-novel, The Dialogues, Conversations About the Nature of the Universe. Applause, please, for the asymptomatically simpatico Clifford Johnson. And I should explain, I meant to say asymptotically, not asymptomatically, because he tweets with the handle asymptotia. Right, next, we have a highly engaged and reasonably public engagement innovator. She's programmed science festivals, set up national programs that reach underserved audiences, not undeserved audiences, underserved audiences, and leads the new creative and partnerships team at the Wellcome Trust. Please welcome Farah Nazir. And lastly, although as with the Famelabbers themselves, the order is random, she is many things, she does many things, broadcaster, writer, gardener, and most significantly right now, chair of this entire science festival. The vivacious, the vibrant, the vivifying, and the occasionally viviparous Vivienne Parry. Not like you to milk it. I feel after that music we should all be arm wrestling or something, but I don't think we're going to do that. So Farah, very briefly introduce, tell us about your new job, because Wellcome Trust, for those who don't know, it's an amazing organisation, second wealthiest charitable foundation in the world. Right. But they're always kind of doing things and reorganising themselves in various ways. So what difference is this new creative and partnerships team going to make?
Well, the main thing is that we've got a completely new vision, which is all around helping the public, and we mean everyone, the world, anyone, to help play their own role in our mission to improve health. So the Creative Partnerships team is doing exactly that. They're looking for opportunities where there's problems that people might be tackling. How can we help use public engagement to solve those problems with them and for them to tell us what we should be.
All right, so Welcome is on the team and teaming up with whatever
Yeah.
subsections of the public seem to be relevant at the particular time.
Absolutely, yeah.
Okay, and Clifford, how about in exchange for you letting me have a free copy, I give you 30 seconds to plug this fantastic and visually stimulating new book of yours.
Okay,
That's a deal. Your time starts now.
Oh, well, it was actually, in a way, an interesting experiment that people responded well to, which I was trying to change the kinds of science book that we put out there, really broaden what we can do. So you experience the science ideas by eavesdropping on conversations, as opposed to hearing sort of an academic do a monologue. And it's all visual. I drew it all myself, and people seem to like it.
Where did this visuals, I mean, have you always had this dormant visual side of yourself?
Well, I've always liked, and I think certainly as a theoretical physicist, you're always thinking visually about how things work. It's sometimes the first thing we do before we actually translate it into mathematics and things like that. And actually, you don't really see that that aspect of it shown in book form very much. So that was something else I wanted to show, that there's a lot of science that's actually done rather visually. And why not use a visual medium like a graphic novel to really engage with
and
those
actually
ideas?
bringing things full circle, the British Nobel Prize-winning chemist Harry Kroto, who came up with the C60 buckyball version of carbon, was also a very skilled artist and often claimed he should have been an artist. And only after he'd come up with the C60 form of carbon did he actually realise it was also the way that some footballs already were designed. So we're back to the World Cup already. So Viv, I've given the other two a chance. Anything you want to big up, particularly now that you're the chair of this mighty festival?
What a wonderful evening. I just love Famelab. It's my favourite thing to come to.
Good.
That's all I have to say.
Well, that's fine. Okay. Now that you're here, just remind everybody, and particularly those who don't know, we saw fleetingly in the video these criteria: content, clarity, charisma. But doesn't it get a bit harder now? These are all national champions. They've all got content. They've all got clarity. They've all got charisma. They've all got this far. What's going to take them the extra yard to that set of trophies that are sitting over there?
Well, luckily, we have content, clarity and charisma. And we are
one
going
each,
to...
yeah.
one each. And I think that they will just have to have that extra sparkle. There will be something possibly nuclear about them. Something that will just up their game and make themselves kind of project more than anyone else.
And go into an excited state.
Go into an excited state.
Excited state. It's plasma stuff.
Yes.
Farah, anything to add? That's what's going to make the difference for you between a kind of got this far, got all the way?
I think they've done so well already to get this far, and I think for me it's going to be exactly as you just say, like seeing their personalities and their hearts kind of come out with this presentation. So yeah, I'm excited.
And you realise their hearts are going to come out and you're going to break a lot of them.
Yeah.
You know, there's 12 of them, there's only going to be one winner and two runners-up. So I'm just
Yeah.
warning you, maths fans, most of you are going to lose. Just the
We
way it
love
goes.
you all, and we don't mean to break your heart.
Yeah.
Okay, fine. Now, all I can tell you is, having seen them in action yesterday, I know you've got a tough job. It's a really tough job. So can we give our judges a preemptive, encouraging round of applause, please, as well?
Thank you.
And remember, the kind of people who volunteer for judging and the kind of people who like to be in front of an audience, they're always kind of media-y people. They're slightly insecure. That means you can play on those emotions by your cheers and claps and yells, so you can make a huge difference to the result as well. One final thing, by the way, I should say, importantly, I know it says in the program this ends at 10:15. There is not a cat in hell's chance of us finishing by 10:15. We've got 12 finalists. We're going to try and get it down somewhere between 10:30 and 10:45. But I'm just warning you, we'll go as fast as we can, but I didn't want anybody to not know that at the start. It's not going to finish by 10:15. Okay, so you're about to see 12 fantastic finalists. But the other Tremi finalists have come a long way from all over the world to be here, and it seemed a shame not to give you just the tiniest chance to fleetingly meet them. So can we have a sustained wave of applause for, are we ready? From Brazil, he came to thrill, Guilherme de Fonte Teles. Bulgarian champion, Boris Yanachkov. Come on, faster, faster, faster. Our new checkmate, Lukasz Pekarek. Egyptian winner, Hossam Adele Abdelwahab Abdallah. France's femme fatale, Assia Azria. Our Greek bearing the gift of the gab, Ioannis Papachristos. I think our femme fatale's not there, so that's fine. Originally from Ontario, our island winner, Sharon Omiwoli. Also not here. From Turin, he came to win, but he didn't. Italy's Riccardo Impavido. There's Sharon now. Stay in order, Sharon, for heaven's sake. A Kazakh standing ovation for our stunner from Astana, Gamzil Imjan Kleboldinov. From Korea and over here, Chan-Woo Park. The victor from Malta, Anthony Galea. In pole position, our sight for Warsaw Eyes, Ruth Dudek-Viher. All the way from SA, 2018 South Africa champion Imogen Dinko. And finally, our Thai guy, Apivich Hamanchan. The draw is silent. Now, if you're counting carefully, I think we were missing two. I didn't see France, but maybe they sneaked past me. I wasn't looking. The one I was expecting not to be there is our Netherlands winner, Jai Santana, and he had to rush off because he's getting married tomorrow. He is getting married tomorrow, and if he had got into the final, he still planned to be here. We have no idea how. Right, okay, so you've briefly met the runners-up, you've been introduced to our judges, you've had the rules half explained, you've had an elaborate topical link to the World Cup. It is time to bring out our first Famelab finalist. Now, the order is decided in the traditional way, which is by dividing the population density of each country by the average number of pets per household and the probability of having seen a Steven Seagal movie. And that means, first up is Bangladesh. They held their first ever Famelab this year, and it was won by a short, fat guy called Alvi Islam. I should stress that a short, fat guy is how Alvi describes himself. He goes on to say he started his academic life with the dream of becoming a doctor, but somehow ended up studying EEE, Electronics and Electrical Engineering. Things may not have gone quite according to plan, but they've worked out just the way Alvi likes. He says, EEE endlessly enjoyable and exciting, and says he's always exploring and finding new things that amaze him. Even better, he loves sharing what he's discovered with others, like he's about to do now. It's an extra challenge being up first, so can we give a double Dhaka welcome to our Famelab Bangladesh 2018 champion, Alvi Islam. Ooh.
And the winner of Famelab International 2018 is, drumroll please, and the winner is Alvi Islam! I really wish what I just said becomes true. But whether it becomes true or not, one thing is true, and that is, most of the times we play drum rolls before announcing the result. Because drum roll makes us more excited, more curious to know the result. Well, drum roll is a music, and music has got control over our brain. That is the real beauty of music. I'm an engineer, but I'm also a musician. And today, I will draw the beauty of music using the color of science. But before that, a musician must play some music. You said you'd always make me happy. You said you'd always be true. You said you'd always keep me warm at night. I didn't know there'd be someone else there too. As you have listened some music right now, it started with your ear, but it connected most of the important parts of your brain, and it did some amazing things. For an example, my music gave you a happy vibe. That's because when you listen to the music, it connected a certain region of your brain, and that region increased a certain chemical when I played the music, and that is why you felt happy, because I played a happy music. But if I played a sad music, the brain would decrease that certain chemicals. But music is not only connected with your emotions, it's deeply connected with your memories too. When we listen music, it connects to the whole hippocampus, the part of our brain which is responsible for memories. And that is why when we listen music, we feel nostalgic. And also, when we learn things like this, I went into a cell, and what did I see? I saw a mitochondria, it's an energy factory. When we learn things like this, we learn things faster and effectively and easily, and those things last longer in our brain. So, as you have listened some music, you know that it has got some power. So from now on, if you feel sad or heartbroken, don't worry about it. Just put on some music and when worries still linger, my friends and I say, top up your cup and let's sing it all away. Thank you.
Well, Alvi, thank you so much. And I'm so glad you played a happy tune, because obviously that's now made us happy judges. Farah.
So you mentioned a little bit there about learning and song and how that can help you remember things. Can you tell us a little bit more about that? Like what favorite song have you got that has helped you get to where you are today?
What favors can come again?
Yeah, so like what song have you remembered that's helped you in your memory and that has helped you get to where you are today?
Well, I am a music lover and I listen tons of music in one day. So I think because of when we listen music, there's a term which is called neuroplasticity that I just did last day. So music enhances neuroplasticity, and neuroplasticity is the way how we learn, because in neuroplasticity our brain changes and that helps us to learn, and music increases the rate of neuroplasticity. So this is how it's connected. So it's not about one song, it's mostly about the music that you love.
Oh. Clifford, super brief question.
Have you put this into practice yourself? Have you actually, outside the context of a competition, have you tried to teach things using music yourself and seen the effect it's had?
Yeah, of course. I live in Bangladesh, so I tried with Bangla music. I remember my teachers used to teach us the name of the matters, so hydrogen, helium, lithium, with music, with Bangla music.
Very good. Top stuff. Thank you.
Very good.
Thank
I'm
you.
glad he didn't sing Memories. One more time, please, for the musical. Song remains the same. Albi Islam. Alvi Islam, by the way, also an anagram of I am A-levels, which is a great name for an academic to have as well. And note the use of the ukulele, now the official instrument of science. So that's bang all there is to it. 3 minutes for them to thrill, 2 minutes for the judges to grill, and then we move on. If, by the way, they go over the 3 minutes, we will hear this. And nobody can talk past hearing a small squeaky toy. Okay. So now we move on to the next Famelab, which in this case is our Cypriot champion, Fatini Kalampilika. A biology student and lab assistant at Nicosia University, Fatini had a few people getting their Nicosia in a twist yesterday when she gave us all an orgasm at 11 o'clock in the morning, which I think is a first for me at Cheltenham. Yeah, I'm sure it's a first. I'd remember. Fatini's presentation on the biology of the female orgasm went down a storm at the Tremi-finals, so the only question is whether what she does now can be anything but an anticlimax, or is that a post-climax? Only one way to find out: a cacophonous Cyprus fuss and some Meg Ryan-style crying for our 2018 Famelab Cyprus winner, Fatini Kalampilika.
Today is Thursday. What color Thursday has? And it's 7th of June. How does 7 taste like? Imagine yourselves listening to your favorite song. You sing along and enjoy yourselves. Now, what if with every note you hear, you could actually see color? Well, if you experience something like that, then you belong in the 4% of the population who has synesthesia. or you're under the influence of very heavy drugs. People who have synesthesia are called synesthetes, and in my opinion, they have a superpower. Taste, vision, hearing, smell, and touch are the 5 main senses that we have. Now, what if the input from one sense, for example, the melody from your favorite song, results in the experience of another sense, seeing a color, let's say? Well, this is exactly synesthesia. But what's going on in a synesthete's brain as they listen to their favorite song? Scientists have found that we are all born with our senses communicating with each other. And as we grow, the bridges between the senses shut down. In a synesthete's brain, though, these bridges never close, and the senses stay mixed. Other scientists support that the problem is actually with the chemicals of the brain, which get confused, and they travel to another place than the predetermined. Almost half of the people with synesthesia have a very close relative that has it too, which indicates that the neurological condition is often inherited. Is it real, though, or does their brain trick them? All of the synesthetes share some common characteristics, which indicates that synesthesia is real, and it's not a memory game of the brain. Synesthesia is involuntary, and the synesthete will always experience the same connection of the senses. Thursday will always be green, and 7 will always taste like beer. Different synesthetes, though, have different experience in the connected senses. For example, one may hear my voice as red, and another one as blue. So bear in mind that reality and each individual's perception are different. That's why you cannot rely on your perception in order to understand the world. And that's why we need science, because it's the only objective approach to the truth that we have. Thank you.
Rotini, thank you so much.
Thank you.
Have you ever wanted to be a synesthete yourself?
Yes, especially the kind of the synesthete, because there are many types of synesthesia, the kind of the synesthetes that could actually see the music. That could be so amazing in a club, you know? Yeah.
And do you think that it has any kind of advantage, evolutionary or otherwise, for people who have this condition?
This condition, yes. Actually, there is a famous, in Greek we call him maestro, the guy that is actually responsible in order to conduct the music in an orchestra. And he actually doesn't hear the music, like first thing he does is sing the colors. So he doesn't like the result of the colors. He's like, okay, can you please make it a bit more blue? And that's how he makes amazing music. And a famous mathematician solves the equation faster because he actually sees colors and shapes, and he plays them together. So it could be helpful.
So our visual artist here, what do you think, Clifford?
Interesting. I could imagine using that superpower as well. Are there ways, perhaps, now we understand from what you were saying about being able to see over time how the bridges break down. Are there ways of artificially recreating those bridges chemically or something to do experiments?
To fix the problem, or
no, to turn it on,
to induce
to study
synesthesia. Oh, I don't think this is possible, and I don't think anybody would like to do that. But I believe that you can really find a lot of things for the brain by studying synesthesia. And I mean, if science evolves that much that we could actually connect the neurons in a way that the senses communicate with each other, then yeah, why not? It could happen in the future, though. Yeah.
Thank you.
Okay, thank you.
The orgasm, then the changing colours. Maybe it's a Cyprus thing. Once more for our synesthete, Fotini Kalampalika. So next on this Green Thursday, and playing with home advantage, we've got our Adroit UK winner, Lucy Guile. Adroit being one of the winning anagrams Lucy found when she appeared on long-running TV show Countdown in 2002, aged only 14, apparently making her the youngest ever female contestant in the show's 35-year history. Now, although she's a Leeds lass, Lucy believes the most beautiful place in the world is the Amazon, apart from the spiders. She's had a chance to sample it, along with Borneo, Fiji, the Himalayas, and a few other exotic locales, as she's a junior doctor with a particular passion for healthcare in remote environments. And now she says her dream will be to split her life between working in the UK and the Amazon, which is better than splitting your life between working in the UK and shopping on Amazon. Lucy's other passion is science communication, and her other dream is to do even better at Famelab than she did on Countdown. And that dream can come true in the next 180 seconds. Get ready to smile, get ready for style from our UK champion, Lucy Guile.
Let's talk about the 5-second rule. Most of you have heard of this, right? This is the idea that when you drop a bit of food on the floor, as long as you pick it up again quickly enough, then it's still safe to eat. Now, this is a fascinating rule that often involves the stretching of time so that the length of the 5 seconds is directly proportional to the deliciousness of the bit of food that you just dropped. But that aside, for those of you who don't use this rule or claim not to, I guess you think it's unhealthy, unhygienic. Germs are bad, right? I'm going to tell you why the 5-second rule is a good thing. Not because that jam donut that you dropped at the bus stop the other week and then picked up and ate, you know who you are. Not because that didn't pick up any germs, but because it did. Now, as a doctor, I see patients all the time with allergic conditions like food allergies, asthma, eczema. And the thing that they have in common is that their immune systems are hyperactive, meaning they try to attack harmless substances in the environment that you come into contact with, causing symptoms. Now, the really fascinating thing is this is a new phenomenon, or the scale of it is. So in the UK, over just the last 3 decades, the rate of hospital admission with anaphylaxis, which is the most severe, life-threatening form of allergy, has risen by, how much do you think? 20%? 50%? It's gone up by 700% in 30 years. That's huge. And whilst the rate of allergic diseases in countries like the UK, and by means sort of westernized countries would normally say, has been going steadily up and up and up over probably the last century or two, actually, the rate of infectious diseases over the same sort of time frame has been going down and down and down. And many scientists think that these two trends are related, giving rise to an idea known as the hygiene hypothesis. Basically, bacteria and viruses have been around for a lot longer than humans, and our immune systems are used to them. The hygiene hypothesis argues that exposure early on in life to a wide range of environmental germs, or microbes they're sometimes called, trains our immune system, helping it to learn what it needs to respond to and what it can simply ignore or tolerate. The idea is that without this, allergies develop. But now, it's not time to stop showering. And in fact, personal hygiene probably has little or nothing to do with whether or not you develop allergies. It's much more likely to be due to things like urbanization, the food that you eat, and maybe overuse of antibiotics, which reduce the range of microbes, germs, that we're exposed to compared to in our evolutionary history when we're exposed to lots more of them. And essentially, this has had consequences for our immune system. So maybe you don't need to be so afraid of our little bacterial buddies. Some of them might be friendlier than you think. You might have to give me a second.
Thanks so much, Lucy. Do you use this to help mums-to-be help them understand that being too clean isn't necessarily a good thing? Because I guess that if people come to you when they've already got eczema and allergies too late, you really need to do this at an early stage.
Well, yes and no. I mean, it's important to differentiate between, good hygiene, which is important. So it's really important to wash your hands after you've prepared, raw meats or after you've gone to the toilet. Those are the things that have prolonged human survival and improved quality of life over the last couple of 100 years. And those things are good. You shouldn't stop doing them. But it's the things that, it's more like the fact that now we don't have as much exposure to the outdoors and that kind of thing that actually seems to be the problem. I haven't used this talk to try and convince any mothers about the benefits of, not
Letting
wearing...
their kids play out, for
yeah,
instance.
so that's really important. And also things like breastfeeding, actually, there's really good evidence that children who breastfeed after birth actually have seem to have lower rates of some allergic diseases, and also things like natural births as opposed to cesarean sections seem to be good for those things. So I might try this talk.
Farah.
How have you been able to use that and put it into context with people who think that there might be a genetic reason for their allergies and eczema?
Well, they wouldn't be wrong. There absolutely is a big genetic component to allergy, and I talked about that a little bit in the final yesterday about the difference between immune responses in men versus women, and there's evidence that there is differences in responses to virus and things, so we spoke about man flu yesterday. So, yeah, essentially, it's a bit of both, and the immune system is this big, fascinating topic that we still have absolutely loads to learn about, and whether or not we'll ever unpick it entirely is another question. But there's lots of interesting, therapies and things coming out of the work that's looking into all the different causes of things like allergy.
Okay,
Thanks very much. There's a looming Quentin.
Yes, we have to avoid the 2-minute rule, otherwise you get contaminated by the judges as well. So, once more, please, for Amazon Prime and Lucy Guile. And I don't want to worry Lucy, but it's one thing to pick up a donut after a couple of minutes on the floor. It's another thing after a couple of minutes on the stage at a science festival where you don't know what chemicals have been on here earlier in the day. Fourth up is our reigning Spanish champion, Juan Magalef. And I mean reigning in the sense you saw the video before he actually got his prize from Queen Letizia in Spain, which is pretty nice. So a mathematician and physicist, Juan is currently doing his PhD in Madrid, although in recent years it's been a case of the brain in Spain stays mainly on the plane, as he's flown to and spent time in Brussels, Vienna, Rio de Janeiro, Erlangen, and closer to home, Barcelona. In each case, as he rather nicely puts it, enjoying their universities and their daily life. He also enjoys talking about his work, especially the way apparently insignificant questions can lead to significant scientific advances. So if he likes insignificant questions, it should be fine when it comes to the judges. But what about the next 3 minutes? No Spain, no gain for Juan Magalef.
This is Alex, a parrot who was part of an experiment about language in birds. He achieved basic communication and could answer simple questions. But one day, something extraordinary happened. He saw in a mirror his own gray feathers, a color unknown to him, and said, "What color?" Alex became like that, the first and only non-human to ever ask a question. It's incredible, just think about it. He was demonstrating his desire for knowledge. Besides, here we can see that the question is actually more important than the answer. And this is something that has happened many times in science, leading to new realms of scientific thought. The theory of special relativity, complex numbers, probability, and many other branches arose from questions that might not seem so important at first. For instance, a great mathematician, Henri Poincaré, studied a question that's especially intriguing to me. What's the shape of a rotating planet? Planets are spherical, right? But surely you've heard that the Earth flattens at the poles. That's because our planet is spinning, so the equator travels faster, making it bulge outward. So our sphere gets flatter, the faster it spins. But could it be as flat as we want? Well, it turned out it can't. Because if it spun very fast, it would be so big and thin that it would become unstable, and any disturbance will cause it to collapse. After collapsing, it will take on a new shape, an ellipsoid, some sort of rugby ball. Interestingly, there exists a dwarf planet called Haumea that spins fast enough to have this shape. Now, if this planet began to spin even faster, this rugby ball will stretch. And again, at a certain speed, it would be so long that it becomes unstable and will abruptly collapse. This time, the shape it would have is even stranger, that of a bullet. This is the answer Poincaré was looking for. But the question gave us much more. Over the years, it led to new branches of mathematics. One of these is the catastrophe theory. It was developed by another great mathematician, René Thom, when he wondered about the mathematics that explain why and how biological structures end up having the shape they have, like cells, organs, Alex feathers. He realized that during these formation processes, abrupt changes were taking place. Catastrophe theory, like the ones for the planets. Catastrophe theory appears in physics, in biology, in economy, even at your breakfast. Because if you put a mug under the light, you can see that there is this lit up section called caustic. we can see that there is an abrupt change in illumination, and this is a true catastrophe. And the same happens at the bottom of a swimming pool. All these are caustics. So you can see that catastrophes are everywhere, surrounding us. So be on the alert for them. In fact, if you are alert enough, the next time someone asks you a question, you might not only respond it, but also open a new branch of knowledge. That being said, do you have any questions?
Thank you very much. And I think the answers will start with Clifford.
Do you have a question that you've been asking that may one day lead to something remarkable?
Yeah, actually. Well, I do.
Can you share it with us?
My work is how can we merge quantum gravity with quantum? How can we mix quantum mechanics with gravity? How can we get to the quantum mechanics? How can we explain the bigger and the smaller in the same theory? Which is one of the open, or the biggest open question in theoretical physics. And I don't know if I will ever make a huge advance on that, but as I said, sometimes the question is more important than the answer. And the question, this simple question, has led in physics to many, many, many new theories that might or not might be correct, but they are giving like a lot of knowledge already.
Are you just saying all of this because you know that's what I work on?
I did my research.
Do you especially value engaging with kids? Because sometimes they ask really profound questions.
I think that kids have a natural curiosity, and we should improve that. And in the sense that they should be asking questions. That's the more important, and maybe not giving them the answers. So yeah, I think it's I don't know if the question was exactly if I do or.
That's right.
Sorry.
No, I thought, I see what that question is very kind of relevant, because children do ask some of the most ridiculous questions. What does Alex ask?
What is Alex?
Alex, your bird.
The bird. It's a real experiment. Alex means avian language experiment or avian learning experiment, because sometimes they were cautious enough to not call that he was able to speak. But it was a fascinating experiment because he was really able to talk. I don't know if that's the proper way, but to communicate. He was able to, for instance, recognize shapes, sizes. They can ask, like, this is bigger or this is bigger. And sometimes he said, they're equal. And this was like, I don't know, for me it's blown my mind. Like, he was able to say that they are equal, which is quite an abstract thing, I think. That, okay, bigger, smaller, we can maybe get it. And he had like a lot of things. For instance, when he get a surprise, he get a prize, and he was expecting over and over again. Sometimes it was not there, and he got kind of angry. He got like, what is my prize?
Well,
Or sometimes when it was, he was surprised.
I think
and
you'll
it was
find
really
you've got
nice.
a parrot lurking
I'm
behind
surprised.
you now.
It's all right, it's all right. I was just thinking next year we'll get Alex to do one of the presentations. Really good as well. He's big on catastrophe, but will he get his hands on a trophy? Juan Magalef from Spain. I love the way he tried to bring in unifying of quantum mechanics and gravity into the 2 minutes of questions, because, you know, we've got a minute spare. We can just sort that out now as well. Next, we have part nerd, part geek, 1,000 parts awesome. Again, it's their own description. Wad Al-Kir, a champion from Qatar. We had a big debate about this during the Tremi finals yesterday. And after going back and forth and consulting a language expert, it seems to be a genuine geographical quantum state where all of them and none of them apply at once. Now, you can tell Ward is really truly part nerd, part geek, because she says 1,000 parts awesome, not 1,000% awesome, because, of course, properly mathematically, you can't have 1,000%. And within those 1,000 parts, she says, 3 principal passions: science, stories, and food. Now, Ward says she entered Famelab simply to practice her ability to talk science and break down complicated topics into engaging stories. So that's 2 parts of her passion satisfied, the science and the stories. I'm afraid the food will have to wait until her 3 minutes are over. 1,000 parts of awesome in 180 seconds works out at 5.55 recurring parts of awesomeness per second. So brace yourself for something that's awesome and then some from our Qatar winner, Wad Al-Kher.
best in this land? Of course not you. Ah, how dare you say that? Look at the endless wrinkles on your forehead, woman. Ouch. It is correct. No, but I don't think it's that bad. Not to mention the countless gray hair on your head. You know what? I don't really want to break you because you will bring me bad luck if I did. Well, I will not let your words break me because there are these magical type of cells that they can actually help me cover up these little things with a little bit of reboot and a little bit of retouch. You know, our body is made up of organ systems. And these organ systems, of course, is composed of organs. And the organs are made up of tissues. And the tissues are made up of cells, which are the basic functional unit inside the human body. After we age, these cells tend to be damaged and finally die, which will affect the tissues and then cause disease in the organs and the organ systems. So scientists decided using something known as the stem cell. The stem cell, we usually get it from the bloodstream or the bone marrow or the umbilical cord. They have a high plasticity, and they actually have the ability to replicate and to differentiate into many different types of cells. For example, right now, if I sit with the judges, I'm a judge. If I went to the audience, I'm an audience. If I find a Spanish person, I say hola. And if I see a French person, I say bonjour. This ability of differentiation made the application of stem cells in the medical field are limitless, basically. Actually, these stem cells possess an anti-aging effect because they are able to repair and regenerate damaged organs that have been damaged by exposure to various toxins and the stress in our daily lives. And now, scientists have been using it as an anti-aging, stem cell anti-aging treatment, for a lot of experiments. For example, they have been taking these stem cells and then injecting them in the hypothalamus of mice, which is basically responsible for all the bodily functions that actually decline as we age. Another experiment, it can also be used in the cosmetic purposes. So it can actually get rid of all the age spots. We can look younger. These stem cells is one of the most effective methods in anti-aging treatment. And it actually gives us that bit of hope that we can age beautifully without any worries. You hear that? I'm gonna get me a dose of stem cells.
Looking very lovely. Farah.
So aging, we have a bit of a problem in this country because we're all getting older and longer, and actually we're kind of struggling with thinking about the resources and how we deal with that. What do you think with stem cells? How can we be mindful of that as well as the fact that we're getting older and actually, yeah.
See, the beautiful thing is, we usually tend to imagine aging as a bad thing. Like, you know, I'm going to age with, I don't know what, with my limbs all over the place. I'm going to not have any tooth in my... What's cool about stem cells is that you can regenerate anything. You just take them apart from your own body. So you're allowing your own body to repair itself, which is really beautiful. Okay, with a little bit of help. You need to get them out of your body first. But you allow your own body to repair itself. And at the same time, you look naturally beautiful. And it's just perfect. It's
very
the perfect
desperate
solution for
concept.
anything.
Yeah.
Do you worry that people will abuse stem cells to
I
give
don't-
the kind of treatments that actually don't work, but people invest a lot of hope in?
I don't think that they will be able to do that because basically it will regenerate an organ. So you will not be able to have an extreme effect out of stem cells. Like you will not be able to have that kind of unbelievable thing or something that is not natural because you are using your own body in the end to repair itself. You're not gonna have a result that you're not expecting, basically. It's something just within you.
Clifford, briefly.
Are there other areas of the application of stem cells that
Yes.
you're interested in?
Absolutely. Imagine, like, there's a lot of disease. Like, for example, if one of your optical nerves got damaged, usually it's not an easy process that you can actually, like, get it recovered. And we can actually do that by stem cells because they will regenerate the optical cord and you will be able to see. That's one of my interests, actually, in the vision area.
Hate to stem your flow, but you gotta go. One more time for our totipotent, pluripotent, Doha star, Wad Al-Khair. So next we head about 6,000 kilometers east-southeast from Qatar to Malaysia, and their 2018 champion, Khairia Mohammed Hanafia, or Kai for short, a lecturer at Malaysia's University of Science. Now, many and varied are the reasons why people say they entered Famelab, but Kai's is one of the favorites I've ever heard. She says she decided to enter after, quotes, observing her husband's eyes glaze over whenever she tried to philosophize the humanity of the adaptive immune response. Exactly the same thing happens with me. Now, Kai's reasons for wanting to improve at communicating science aren't just limited to entertaining her husband. She says that she hopes her efforts, and again, quotes, will ensure that her sons grow up knowing that cleavage isn't just a gap between bosoms. Great image. So now she's got her family and Famelab Malaysia sorted. She's come here to Cheltenham to sort us too. So prepare to be bosom buddies with our amazing Malaysian champion, Kai Mohammed Hanafia.
If you had to choose to fall into the arms of someone in this crowd, wouldn't you rather fall into the familiar arms of a friend? Well, that's how antibodies choose the antigens that they want to bind to be locked in a molecular embrace. In fact, antibodies can only bind antigens, which are pieces of bacteria or virus, that they've met before, that they recognize as familiar. It is this familiarity and exclusive match that forms the basis of many of our innovations in biomedical research. Particularly for my research, the specific recognition of antibody to antigen can be used as biomarkers and turned into simple diagnostic tests, like a pregnancy test, but to diagnose an infectious disease. Now, usually, antibodies recognize antigens better than you would recognize the face of a loved one in a room full of strangers. But a problem arises when sometimes antibodies mistakenly recognize a similar but different antigen, the way I might mistakenly recognize Brad Pitt as my husband when I'm not wearing my glasses. Now, this is a common problem in developing an antibody-based test, but especially to diagnose TB, a disease that afflicted 10.4 million people just in 2016. This is partly because the bacteria that causes TB, the Mycobacterium tuberculosis, has many mycobacterial cousins that our bodies constantly meet in the environment. This confuses an antibody-based test and gives rise to false positive results, which reduces its accuracy. That's why, even until today, we are stuck with methods to diagnose TB that are time-consuming, expensive, and laborious. And most importantly, they will miss the majority of people living with TB in areas without lab facilities, depriving them of a cure. That's why my research is investigating different mycobacterial antigens and how our antibodies recognize them. Hopefully, one day we can discover an antibody-antigen match that can be turned into a simple diagnostic test to diagnose TB in big hospitals as well in remote villages without running electricity. Such a discovery could be the difference between containment and spread or life and death. Such a discovery could be an antibody-antigen match made in heaven.
Thank you very much. Is this the same reason that lies behind the vaccines for TB not being nearly as effective in some countries as they are in others?
That's a great question. It's not exactly the reason why the vaccines don't work. The long perception has been that antibodies in TB are essentially useless. But the real reason why a lot of the vaccines don't work in adults is because the way that we make a response against the actual TB bacteria as well is very slow. So even when you vaccinate, it does not mount a quick enough response. So it's not so much whether or not it's a good or strong response, it just doesn't come soon enough. But linked to antibodies, one of the reasons why we're struggling with vaccines for TB as well is we don't know what are the correlates of protection. We know antibodies don't mean the person's protected. So it's very difficult to actually measure what gives protection against TB when we're trying to find new vaccines.
Thank you. Clifford?
I was just wondering if you mentioned the various sort of cousins of TB that we encounter quite regularly.
Yeah.
What are the sources of those? Where are those found?
They're everywhere. The term is they're ubiquitously found. The other term for them is environmental mycobacteria or non-tuberculous mycobacteria, mainly because, one, you can't get them from another person. So if you are infected by them, they can cause disease if you are immunocompromised. So if you get them, then it means you've gotten them from the environment. But they don't cause the tuberculous type of disease that Mycobacterium tuberculosis does. And they're quite varied in their sources. There are different species that prefer certain places. For example, there was a report a few years ago, actually, about women in a menopausal age getting these lung infections. And they discovered that it was because there was Mycobacterium avium in the water supply that they were drinking. And usually it wouldn't make, probably you and I are sick, but there were certain people that were actually getting sick from it being in the water system. So water system, very common to get mycobacteria. Soil, we've done some studies in Malaysia. It's in the paddy fields. It's in the waste sites. It's everywhere.
Thank you.
Okay, antibodies not from anybody, but from our Qatar champion, Kai Hanafa Atia. And just a thought, Kai, if you might mistake Brad Pitt for your husband if you're not wearing your glasses, is it possible it's Brad Pitt's eyes that are glazing over whenever you try to philosophize the humanity of the adaptive immune response? It's just a thought. Right, we're halfway through the final, and Malaysia is just over halfway to our next and furthest flung Famelab destination, Australia. Their winner, Vanessa Perotta, has come over 17,000 kilometres to be here. How far over kind of depends on the route she took. 17,000 kilometres, that is a vast separation, which oddly is also an anagram of Vanessa Perotta. It's a little harsh, I feel. I was well under the 3 minutes, I'm absolutely sure of that. Vanessa, though, is not just about separations, though. She's about cetaceans and conservation, helping protect and preserve whales. A PhD student at Macquarie University in Sydney. In the Tremi finals, Vanessa gave us a whale snot snapshot, explaining how she uses drones to collect the contents of their nostrils. And perhaps more importantly, explaining why. Now, since seeing her do that, I've worked out that Vanessa Perotta is also an anagram of trap snot via sea, which is pretty much what she does. So that is nominative determinism in anagram form. Tonight, though, snot that again, or maybe it is, bound to be a whale of a tale from our Australia champion, Vanessa Perotta.
Do you have a pet? A cat? A dog? Perhaps a goldfish? Or maybe you don't have one at all. Regardless, we all know that from time to time, in order to look after an animal's health, one might take them to a vet. But how exactly would you conduct a health checkup for an animal that can weigh as much as 80,000 kilograms and reach lengths of over 17 meters long, such as a whale? My answer, whale snot. which is that visible plume of spray rising from a whale's blowhole, which contains biological information such as bacteria, which we can collect to provide a checkup of a whale's health. But how exactly do we pick a whale's nose? Well, previously, health information from whales came from those in which had stranded, in which case their health was compromised, or from those that were deliberately killed. And current methods to collect whale snot involve scientists being on a boat with a long pole and a petri dish and holding this over a whale's blowhole. But this can be dangerous, as a whale could actually flip a boat. So to make collecting health information from whales easier, I collaborated with drone experts in industry, and together we designed and built waterproof drones with remotely operated petri dishes for collecting whale snot from northward migrating humpback whales off Sydney, Australia, for an assessment of whale health. To collect our samples, we hopped on a boat. Then once we saw a whale, the drone was flying from the back of a boat all the way over to the whale's position. Then as the whale took a breath, the petri dish would open. The drone was then flown through the densest part of the whale's snot. Immediately after, the lid was shut, securing the sample as the drone was flown back to the research vessel. Overall, we collected 59 samples of whale snot. I then used forensic techniques to try and identify the types of bacteria living in whale lungs. And interestingly, I found these whales shared similar bacteria with Northern Hemisphere whales, but I also found out that these whales are acting as massive mobile monitors of our ocean health, collecting bacteria as they travel from their cool feeding waters of Antarctica, past the beaches off Sydney, which I swim in, and all the way to the warm waters of Northern Australia. And then doing that all the way back again each and every single year as they migrate. My research is transforming the way in which we collect health information from whales without having to hurt them. Drones really are giving rise to a new era in whale conservation. And I'm not joking. Thank you.
So I've got to ask, how smelly is whale snot?
It depends. If they're just fed, it can be really fishy, or krilly, I should say, because the humpback whales that I work on, they predominantly feed on small Antarctic krill, which are really, really tiny little organisms.
Farah.
So what a brilliant use of technology for research. Where do you think the next advances are with this kind of research? Because I see what you've said there. There's a really challenging environmental side to understanding whale health. Great use of drones. What's next in the pipeline?
Thank you very much. It is a really exciting piece of technology for whale research. I think the next step would be furthering this research with drones. Not only are we able to collect whale snot, which is great, but we're also getting this new snapshot of whale behaviour from the sky. When you see a whale from a boat, you're limited as to what you can just see. But when you launch the drone from the sky, in which case what we're doing with our research off Sydney, we are seeing a whole host of new behaviours, interactions with different dolphins, inter-pod relations, whales sometimes getting a little too close for comfort with each other. It shows you a whole different insight to whale behaviour. And we're also trying to adapt these to other marine mammals, such as small dolphins and other species. In fact, in the future, I would like to take what we've done on a population which is considered a conservation success story to more threatened populations, such as the North Atlantic right whale or the southern right whale in Australia.
Clifford.
How many drones did you lose?
Great question. 0. It was a really wonderful industry collaboration which I've been working with actually a pilot from Cheltenham. And it's a fantastic opportunity to learn in the field before you actually go and sample. And thankfully, the drone we actually had was not this one. It was a little bit too logistically challenging to bring to the UK. But the ones that we have in the field has flotation devices, which if we do lose them in the water, are able to float and we can retrieve them.
Just hope that the whales don't eat them.
Yes.
Right.
She's from New South Wales. She knows the truth about whales.
Thank you.
One more time for our Whales That Have Oz, Vanessa Perotta and her drone. And that Is our globe-trotting done? The final 5 Famelab finalists are all from Europe. And the first of them is our Portugal, not Portuguesa, Barbara Pinho. From Aveiro, the Venice of Portugal, Barbara is studying for a biomedical degree at the university there. But that wasn't always the idea. As a child, she was absolutely determined to be a writer. Only when she was older did she realize that her true calling was becoming an equine vet. And later still, she alighted on a real vocation, journalism. So, says Barbara, funny how I ended up in biomedicine. But now that she's started to do science communication, she says, she's begun to realize there are opportunities by attaching that around her research to do a little of all the other things she wanted to, provided, she says, she can find somewhere to put the horses. So, we've stabled them outside for tonight, so you can get 3 minutes with part writer, part vet, part journalist, part biomedic, all Famelab Portugal champion, Barbara Pinho.
Thank you. When I was a kid, I was afraid of the dark. And I thought that once I'd grow old, I'd no longer be afraid of it. I was wrong, still afraid of it, and even more stuff. Surprisingly, humans, I think, are all afraid of the dark. It's just a different kind of darkness. I call it the darkness of the unknown. We are all afraid of what we don't understand. And today, I'm bringing a truly terrifying topic here to the stage. I'm talking about cancer. Cancer is a terrible disease, which has been killing a lot of people. That's why I'm not only talking about this pessimistic side of life. I'm also talking about an extraordinary one. GFP, green fluorescent protein, a small, non-toxic protein. And what makes it so spectacular is the fact that it shines a green fluorescent light once we expose it to ultraviolet light. This protein can be super useful if we attach it to some other structures, because afterwards we can see the path of those structures. All we have to do is to link GFP and an interesting structure. After that, we need to expose the system to ultraviolet light. And finally, we need a scanner which will generate pictures of what's going on. And finally, we can see photographs of the path of our structure, which is illuminated by GFP. Okay, I know this is a brilliant idea. However, how can we use it when it comes to battle cancer? Well, GFP can be very useful to perform earlier diagnosis, which is to understand as soon as possible if a patient has or has not a tumor. And this can be very challenging, mostly because tumors can be very small and difficult to find. And something that makes it even more complicated is the fact that on the inside, we're very dark. Just like you there in the audience. There's so much light here, but no light at all that side. If me and the jury wanted to see, for example, one nail on that side, if that person, I don't see a thing, but if that person wanted to put their finger up and I wanted to see your nail, it would be super difficult. But what if that nail was shining with a green fluorescent fabulous nail polish? The job could be done. And this job has been done. And I know, it's truly a creative idea, right? To put light to tumors. However, science needs that creativity. Today, we celebrate science as concise, objective, but let's make it poetic. GFP can truly be the light at the end of the tunnel, and there's no reason to be afraid. Not today. Actually, let's be hopeful. After all, GFP is green, and green is the color for hope. Thank you. Thanks.
Thank you. Clifford.
Were you tempted to have someone in the audience with green?
I was super tempted, thank you. I really want, but then it could not work, so I didn't do it. And it's super difficult. I really don't see a thing. I was just pointing. I probably pointed to a chair, sorry. But it happened. Yes, I was very tempted, indeed.
How do you decide which tumours, if you've tagged them with GFP, which ones are going to be the one? Because if you're getting really just very, very tiny ones, how do you know that they are going to grow into tumours that are going to be an issue?
In the project being done with this, instead of using GFP, like a cousin of GFP was used, red protein, because that's the research team, they wanted a different color, that's all. Really. But the way they tracked the tumor was through viruses. It's like, imagine you are a passenger and you need a bus to go somewhere, so the virus would contain the protein, and the virus was targeted to the tumor, and they would go around the tumor, so they would lighten up those small tumors. Even if they're very, very tiny, the viruses are so many that you can actually see it.
So this sounds like really brilliant technology that can help identify cancer at the very, very early stages.
Yes.
But of course, a lot of people are really fearful of cancer, and often it's a really tricky thing to be able to go to the doctor and see. So how is this used at the right moment? How do you get patients and the public to feel like they can come forward to use this treatment?
Well, my approach would be to show them all the diagnosed methods we have. Some of them are really hurtful to patients. For example, X-rays, they're not healthy at all for you. So if I had a patient and if I was a doctor, I would tell them, so dude, we have A, B, and C, and you have D, and D doesn't hurt you, so maybe it's the best choice for you. However, we're kind of far away to do that. It's still on research. So the team which I researched on, they are trying to do this in 5 years from now, but it's still too early to decide that, I'd say. So
Okay.
that's all.
Thank you very much.
Thank you. Thank you.
Brilliant. I love the way Barbara said she'd say, "Hey, dude," when she was treating the patient. Right. In at number 9 is our Famelab Germany winner, Veli Vural Uzlu. As you might guess from his name, Veli is of Turkish extraction. As you probably can't guess from his name, he's a National Olympiad double medal winner in chemistry and maths. He got his BSc in molecular biology in Turkey. Then he had interesting international internships in Italy and the US, and then did his PhD on mouse developmental genetics at the European Molecular Biology Laboratory in Heidelberg. After that, he finally stopped moving, or at least moving far. Veli's still in Heidelberg, but he's now at the university's plant physiology department doing his postdoc and using all the time that's been freed up from not traveling to do things like, well, enter and win Famelab Germany 2018. Now he's here, hoping, like Julius Caesar, to be able to say, Vene, Vidi, Vici. Please welcome Veli Vural Uzlu.
Hello, children. I am a virus. You don't recognize me because I am a good virus. I went through an integration phase, and now I'm a part of you all. I'm happy here. I work for you. But on the news, you never see good viruses. Journalists always mention about HIV, Ebola, but when you guys unraveled the human genome, it turned out that there are 100,000 viruses that are a part of your DNA. Just to put it in perspective, what makes the difference between you and an ape is only 1% of DNA. And we viruses make 8% of your DNA. Can you imagine how you would look like without us? For example, I make a protein called syncytin. This is the protein that you all use to attach to your mother's uterus during the pregnancy. Long time ago, before you were mammals, I met your great-grandparents. They were very open. They hosted me. And in return, I made them syncytin. Thanks to the tolerance of your ancestors and my skills, of course, now you spend the first 9 months of your life in a 5-star hotel in your mother's belly. Your ancestors sometimes acted, excuse my French, a bit like an asshole. In 17th century Dutch paintings, the tulips have the most amazing patterns, most amazing colors, not before, not after, only in this short period of time. The DNA of these tulips contain an old friend of mine, a mosaic virus. A beautiful one. She got into the tulips, she integrated herself randomly, and every integration was a new pattern, a new color, and then economic crisis. good viruses are the first ones to exit or to be kicked out of their host in stress conditions. This is not good for the host, this is not good for the virus, and this is called vir-exit, virus exit. This is the beginning of an unknown journey for us. So, coming back to the 17th century Holland, the Dutch king said, Netherlands, hate to the color, which means, let's kill the tulips. And from that moment on, my friend couldn't find a host. She became extinct, and those beautiful flowers extinct forever because of a dictator who couldn't stand diversity. Cheltenham, media is showing me and my friends evil just because there are a few bad viruses out there. We are hundreds and thousands, and we are a part of you. If you don't tolerate us, you erase the most beautiful colors from this world. And if you tolerate us, we provide you an environment as safe as your mother's belly. Dear Cheltenham, you are lovely. Thank you.
Thank you so much for that. So can we use the way the viruses are incorporated into our DNA to smuggle medicines into cells that are perhaps sick? They've got their DNA is mutated.
This is, at the moment, a bit hard to do. The reason is the integration is, as I said, random. So sometimes they integrate at the parts that are very important for our physiology. That's why we don't want to risk it, so we want to do it with more controlled methods in our hands. But nature is doing it, it has the chance randomly, but we would like to do it more targeted. That's why the viruses do not seem to be the best tools for it. We have even better tools, actually, in this case, to target certain sites to
Ooh,
deliver
I think
genes.
he's telling us he's a bad virus after all. He's a bad virus. Farah.
So you mentioned some really big diseases like Ebola and all of these other things that are kind of connected to viruses. And obviously, certainly at the Wellcome Trust, we're really interested in trying to eradicate those diseases. And as you mentioned in the news, we kind of talk about that, and we don't really get that much. We don't talk that much about good viruses. Are you kind of are you concerned that there's too much narrative then around bad viruses? And do you think this is going to have an effect on how we might look after ourselves for the good viruses?
The problem with the viruses is the definition is very large. So we have to talk about virus by virus. One virus can be good, the other one is bad. So we have to treat everything in a very particular way. That's why I think it is important also for the cancer that the cancers are different from each other. We really have to address cancer by cancer, virus by virus, person by person. That's why it is very important to not take everything in one sphere, basically.
Thank you.
Briefly, Clifford.
I'm just wondering if, in terms of strategies for getting the awareness, it's a complicated issue. And do you have a sort of number one priority for how you sort of simply but accurately sort of make the biggest difference in changing awareness?
This is a difficult question. The awareness is about reaching the public, but I think most importantly at the moment is to reach the public in a way that we deliver scientific information rather than anything that is being tried or that is not real science. So for me, the take-home message is if there is something scientifically proven with different methods, it has to be delivered. And my priority would be, in this case, scientific accuracy. Yeah.
Addressing some very viral issues, it's Veli Burul Uzlu. Next, and anti-penultimately, we hop across the border from Germany to Switzerland. First time we've had neighbouring countries all night, back-to-back all night. And as you might surmise from his name, our 2018 Switzerland winner, Dmitry Kopolyansky, is not Swiss. He is Russian. As you'll also gather, if you're a Famelab regular, this is very much a norm. We're on a bit of a non-Swiss roll. With every year, most of the winners of Famelab Switzerland, if you don't appreciate the jokes, you don't have to be on the panel. Don't have to be there, right? But we've had a lot of really great Famelabs, including people who've gone on to be international champions, have come from Famelab Switzerland. They've just not been Swiss. Not sure why many Swiss people don't enter. Not sure why the Swiss people who enter don't win. But the good news about this is we've as yet no competition in Russia. And by that I mean no Famelab in Russia. That's not a political statement about what's going on in the country. Right, okay. But we have managed to get a Russian into the final. Dmitry says after finishing at Moscow Medical Academy, it took him 2 years to realize that if he wanted to study tropical diseases, and he did, then there really weren't a lot of tropical diseases in Russia. So he went off to slightly more tropical places like Israel, Germany, and eventually the biochemistry departments at Lausanne University in Switzerland, where he's now based. I did say slightly more tropical. Dimitri's particularly interested in how our immune system battles these infections. And he's also worked out a few ways, he says, to overcome immunity to science. Things like humor, drama, and, well, you're going to see in the next couple of minutes. So get ready for some applause, please, for our big Swiss cheese, who's actually Russian and who says that the next 3 minutes will change the future of one person in the audience, Dmitry Kopolyansky.
Love. Love drives us crazy. It makes us do stupid, dangerous things. Love is a disease. And since I'm now here, I want to confess. Confess that I'm madly and deeply in love. In love with my cat, Boris! Isn't he cute? Our love was perfect until Boris met someone else. It all started when Boris got slightly sick. He had a parasitic infection. I actually think that the Boris is a parasite himself because he only eats, sleeps, and plays around. But at the time, he got infected with Toxoplasma, a tiny parasite that wanted to live and multiply inside the guts of Boris. Boris wasn't really happy about it, so he decided to get rid of the parasite by pooping it out. But Toxoplasma really, really wanted to come back, so it waited for the Boris's mortal enemy to appear, Mr. Mouse. When it got inside the mouse, it needed to convince him to go find Boris, and for that, it developed a very, very evil plan. It migrated into the brain of Mr. Mouse and forced neurons to produce dopamine, the molecule which is responsible for feelings of excitement, joy, and love. So Mr. Mouse became very happy and romantic, but still he didn't want to go find Boris, because mice have an innate fear of predators. If they smell them, they run away. So parasite accumulated in a special region of the brain which controls fear and anxiety, and totally messed it up. So instead of being afraid, Mr. Mouse became very, very attracted to cats. All he wanted is to run into Boris and make sweet, sweet love. Boris was very surprised. He just opened his mouth and let Mr. Mouse run there. Love became deadly. Certain parasites are able to control behavior of their host in order to ensure that their life cycle gets completed. But what if parasite doesn't get inside the mouse? What if it gets inside us, people? In fact, 1/3 of the world's population, well, you included, are positive for Toxoplasma. Look, I'm not saying you ate a cat's poo once, okay? And even if you did, it's fine. UK is a free country. But probably you got it with undercooked meat or unpasteurized milk. Our immune system is able to protect us, but some parasites may remain in our brain. Do they affect our behavior? Still not fully understood. Do they make us love cats? Well, with me, it's fine. But remember, Boris is mine.
So lots of tropical diseases are parasitic, but why did you become interested in tropical diseases in a very cold bit of Russia?
Well, I'm from Moscow, so it's not that cold as you think, but still. Well, so when I finished medical school, I was quite young. I was 22, I think. and I was driven by this idea to go somewhere into tropical countries and help people, and it brought me first to Research Institute, which belonged to my university, where I worked with tropical diseases in a laboratory. But then, as Quentin introduced, there are actually not that many of them. So I decided just to change my life and go explore this opportunity, because I was basically driven by the idea to do something useful, and also like I wanted to study this and just wanted to go somewhere far away and challenge myself. And then I decided to study parasites because I think parasites, they always have a story to tell. They're so amazing. And most of the people associate parasites with something like creepy insects, ugly things, and majority of them are, that's true. But the way they work is absolutely amazing, because evolutionary, I think it's one of the most amazing relationship between organisms, because they're able to survive harsh environment, adjust, and also take maximum of what they can from the host. So also keeping the host alive. So they would use resources of the host in order to reproduce and go on with their life, but at the same time not killing the host in this instance. And I mean, I study another tropical disease and another parasite which is called Leishmania, of which I talked yesterday. And I'm just fascinated by parasites in general, because they're really cool.
I think he's a man in love with parasites. Have you got a quick question?
Has anyone been thinking of applications for this? The hosts controlling.
You mean the behavior control?
Yeah.
Well, like give everyone toxoplasma and they.
So you would be
change
surprised, but in life there are other examples when exactly parasite can control behavior of the host. I can list them for quite a long time. It would be interesting to think if there would be application useful for people. I'm afraid these kind of experiments would not be approved. But if you'd like to manipulate someone's behavior, I think you find it's better to find the right words rather than infect them with a parasite.
Hang on. Dimitri, just before we let you go, you asked me to introduce you with a specific line about the future of one person in the audience will be changed. Yes. Which was the one person?
I will not say that.
Okay, it's a secret.
Of course.
Okay, that's nice to do an in-joke in front of a huge audience. Okay, it's good to... He says, parasites always have a story to tell. We found the person to tell them. Our Russian-Swiss champion, Dmitry Kopolyansky. So head due east, less than 1,000 kilometers from Lausanne, and you will get to, I won't turn it into a test, Hungary, and their first ever Famelab winner from their first ever Famelab competition, Agnes Kisthoff. Like Barbara from Portugal, Agnes has also changed her mind a few times about what she wants to do. First, it was mathematics, then it was teaching, then it was mathematics and teaching, and then, as Agnes put it, she succumbed to the temptation of physics. Clifford, do you know how that feels? And now she's gone even further to become an astrophysics PhD student in Budapest, working with cosmological ionized bubbles. Not your ordinary ionized bubbles, cosmological ionized bubbles. She's come this far. Kind of hope her bubble doesn't burst now, or she'll be really kissed off. Applause, please, for our last but one finalist and first ever Hungarian champion, Agnes Kisthoff.
Black holes are the most mysterious creatures. Everybody talks about them, but no one has ever seen one. Does that mean that they don't exist? Of course not. The truth is that a black hole is less like a unicorn and more like an invisible baby. To illustrate this, invisible little Charlie came with me today, so let's put you here. And of course, we brought you a black hole as well. If you please, thank you. Just put it here. The first similarity is absolutely striking. They are both invisible. The child probably inherited it from his grandfather. The black hole, however, is invisible because extremely large mass is concentrated inside a tiny little space, it has such strong gravitational effect that even light can't escape from inside. And without light, there is no sight. Then how do we know that they are actually here? Because they are both influence their surroundings. Admit it, if there is a baby in the family, then mommy, daddy, and all the sibling life will gonna affected by this little Tara's needs. If we just observe the family members' behavior, we're gonna find out that there is a baby in the family, even though we do not see him. A black hole is exactly the same. It has such strong gravitational effect that all the surrounding stars will gonna circulate around it. If we just study the movement of the stars, since they are visible, then we're gonna realize that here, right here, a black hole is definitely has to be. Oh, I think the little baby just got hungry. It's not a surprise. He is from Hungary. And everybody who ever tried to feed a little one knows that only some parts of the food will land in his mouth. The rest we're gonna cover roughly everything else. And if he starts to cry, then all the neighbors will gonna know that little Charlie is just having his lunch. I don't know if you ever tried to feed a black hole, but it's the same situation. If it finds something to consume, it gets so eager that things get messy in the process. Its food is not exactly baby food, rather some hydrogen, stuffed with little helium and topped with just a pinch of interstellar dust. But only some part of the food will land in the black hole's stomach. The rest will simply radiate out and cover the surrounding space with light. So that black hole, which was almost unnoticeable before, wolfing down its meal so spectacularly that it can easily outshine even 1 billion stars. And not just all the neighbors, but almost all the universe will gonna realize that this black hole is just having its lunch. So, are they still mysterious? No. We believe in lots of things we cannot see. God, love, bacteria. But when it comes to black holes, we don't need faith, we just need to think outside the hole. Thank you all.
I want to know what galaxy is on your skirt.
Actually, I don't know. I buy it online, so they didn't give me a menu.
This is one for you, Clifford. Not the skirt, the...
It would be nice.
The baby,
it's hard
put off by the skirt.
One of the exciting things that's been going on in black hole research, as you probably know, is that we're learning a lot about them from when they bump into each other.
Yeah.
What's the analogy with the baby side of things?
The two babies get together. Yeah, I wasn't thinking about it, but maybe that's just, something which is specifically into invisible babies, Maybe regular babies are not doing the same, but if you have invisible babies, maybe at some point, you have to be careful to take them apart, because if they get together, maybe at some point they emerge. And you're just gonna end up with one baby in the end.
I thought that was an interesting analogy of the baby and the people reacting to it. So visibility, I guess, is you can't see the black hole, but like what examples can you tell us about where you've seen this black hole and that we could look at ourselves to see this light kind of being...
I'm sorry, but
the black holes, and you mentioned how like we can't see them, but we can see
them, but we can see the effect. How do you say it? They affect the surrounding areas. For example, if there is a star, there are lots of different types of black holes. There are smaller ones. They're actually just similar mass than a star, and they are just. We just saw that the star is, circulating with something invisible. And for example, if it's a very massive black hole, like in the center of galaxies, then we actually can see stars circulating around it, like in our own galaxy as well.
Okay. So lots
so
of diversity
we see the effect of the black holes most of the time.
Thank
Yeah.
you.
Okay, black holes, babies, and much, much more from a Hungarian champion, Agnes Kishkov.
Oh, I'm sorry. I have to take Charlie with me.
Oh, don't forget.
And don't forget the black hole as well.
Can I just give her?
Yes.
Right, okay. I wonder if when black holes bump together, is that like burping babies, maybe? I was trying to think of some kind of analogy going on as well. 11 down, 1 to go, and the remainder is Romania. We've saved the Bucharest to last, but have we saved the best to last? There's an 8.33% recurring possibility that we have. Our Famelab Romania champion, Mihnea Ioan Nicolescu, trained as a surgeon, but then decided there was something he liked even more: teaching. He's now a lecturer at the Karol Davila University of Medicine and Pharmacy in Bucharest and runs the first Romanian module on regenerative dentistry. Mihnea says he teaches students about cells, tissues and regenerating teeth, and also sometimes about coffee and board games too. He's helped their dental skills, he's helped their mental skills, and he'll do the same for you in the next 3 minutes if you just sit back and open wide. Get ready for tooth truths and incisive incisor wisdom from our reigning Romania champion, Mihnea Ioan Nicolescu.
Not a long time ago, not in a cell far, far away, something happened. Then 2 cells appeared, then 4, then 16, and soon a brand new organism stepped into the world and increased its population by 1. One organism that is made of organs. Organs contains tissues, and tissues are made up of cells, and by cells, by stem cells, as you all previously heard. But what are stem cells? Stem cells are very special cells that instead of dividing into 2 identical cells, they split into 1 stem cell and 1 normal cell. And I know so many of you believe that, okay, we have stem cells only at birth in our umbilical cords. No, we have them before birth, at birth, and after birth in our adult life. They are spread all over our organs, where they act like a natural repair system, replacing old or damaged cells. Okay, that's interesting. We have stem cells. What can you do with them? We can repair things. Let's repair teeth, damaged teeth. Wouldn't it be nice that instead of repairing them with, I don't know, metals, resins, plastic, can we use our own body parts that are produced by stem cells? Of course you can. Do we have stem cells in our mouth? Yes, we do. Where? Everywhere. We have them in our teeth. We have them inside them. We have them along their roots. We have them in our jaws. We have them in our gums. We have them even in our salivary glands. And they are just sitting there, waiting to repair our teeth. And not just our teeth, but also other organs, such as our heart, such as our eyes. And why? Because we have them. They are our stem cells. And stem cells are everywhere. Why those inside our mouth? 3 reasons. 1, accessibility. You can see your teeth, you can see your gums. 2nd, medical efficiency. Imagine baby teeth, an excellent source of stem cells. They just get wasted because Tooth Fairy does not know anything about regenerative dentistry. And 3rd, compatibility. They are your own cells. They are compatible with you because you are compatible with them. You are all compatible with each other. And all of these are brand new, I know, are brand new instruments of a new science called regenerative dentistry. This is the new kid on the regenerative gang, and possibly the one that you will be hearing 10 seconds from now, regenerative dentistry. Thank you.
So if you look at an organism like a shark, sharks constantly replace their teeth all the time. Why don't humans just naturally replace teeth? Why do we have to think about regenerative medicine in the way that we're thinking now? Why don't teeth do it for themselves?
Because sharks have many and many rows of successive teeth. And when they break one or they lose one, they just flip to the next one. They already have formed several and several rows of teeth. We only have 2 and 3 if you count the one that we put in dental office. But nature only gave us 2, the baby teeth and then the adult teeth. So that is why we don't have any more buds that form our teeth to form another generation of teeth. So we are just limited at 2.
Boring. No, boring. We can't make new teeth.
I know,
Farah.
unfortunate. How far away is that technology then, and how expensive is it going to be, do you think?
She'll be round.
Yeah, so the first question, it is not that far away because already teeth can be regenerated in vitro and also in vivo, but not in humans, in mice. Teeth have already been regenerated here in UK, in London, at King's College. And the only problem is that we still have to determine the orientation of the tooth that gets regenerated. I mean, it gets regenerated, but it's not quite there yet how we should
So
intend to.
crooked.
Yeah, so, and back to the second question, it's way more expensive than it would be on a dental implant. So we calculated it will be roughly £10,000 for one tooth, so it's still not there yet.
And then you've got to add the Ryanair fare.
Yeah. And then the extra dental treatment to get them the right way around, right? Braces.
Not quite.
Oh. Thank you.
Clifford.
Is there a reason you think this is going to be on the horizon sooner than other regenerative medicine treatments? I got the impression that's what you thought.
Yes.
Why?
Because we already have a lot of source accessible, and not we do not have to spare any vital part or something that we can get harmed. We just have baby teeth, we have wisdom teeth, and we can just extract stem cells from there, grow them, and then either reprogram them or just use them as they are in order to facilitate their direction into one organ or another. But the comparison with other stem cell sources is that we can grow them in larger number using something that we would throw away. So it's just, as I said, medical efficiency.
Okay, I better stop you there before you have to charge a consultation fee. Can we have
Can I say one more thing?
If you'd keep it quick.
I would like to be very welcome because today, on the 7th of June, British Museum was founded, and I held a science presentation in Brittany. Thank you.
Oh, that's very nice. Okay.
Thank you.
An extra big ovation. The shame of it that it took somebody from Romania to tell us it was the anniversary of the British Museum being founded. Dearie me. Well, that was the last Famelab of the night, the last of the 12 tonight, the last of all 27 that have been with us in Cheltenham. Do you not think they have been Famelabulous? And exactly, they deserve, all of them, to bask in your warm applause and the sense of togetherness that only Famelab can bring before they are cruelly riven apart and turned into winners and losers by this vagabond group, our judges. Or, to be accurate, into one winner, 2 joint runners-up, and then 9, how do we call this? Not winners. What's the technical? Losers, that's the one I was looking for. Fine, okay. Now, it's harsh, I know, harsh, and it falls to the judges to be wise, be powerful, but above all, be quick.
Yes.
We will send you on our way. We want you back in 15 minutes. Can we send them on their way with some applause and cheering to get them on their way?
Right, where are we going? That way.
Now, while they are off to cogitate at a high rate, we get to decide on the audience vote winner. And by we, I mean you. I'm not involved. And by you, I mean you only if you've brought along some sort of device that can access the internet. So if you've got a smartphone. Now, regulars will know we have a long and what we can only call suboptimal record of using technology to vote in Famelabs, and yet we keep coming back for more. This year is no different, and rather alarmingly, the voting in the Tremi-finals actually went really well. So if I didn't know there's no such thing as cumulative probability, I'd now be getting really worried. So here is what to do. First, please, if you can, get out any device that you have that can access the internet. If you don't have such a device with you, it may be the perfect opportunity to introduce yourself to that really interesting looking person in the next row or the next seat and have a quick chat with them about your favorites for voting. Okay? Now, then use it to what we need to get online. Behind me, yes, good, it is appearing, that's excellent. So please choose the Wi-Fi network voting. The voting code is voting18. If there are under 18-year-olds in the audience, you can still vote, and also, sorry about all the orgasm jokes. Once you've done that, go to live.voxvote.com and enter this PIN number 72139. Now, if all has gone well, that should open up a list of the 12 Famelabbers you've just seen, and you'll be able to vote for whoever you think was best. I stress voting is anonymous. So there is no reason to be loyal to friends or fellow countrymen, partners. They will never know. Vote for who you think gave the best combo of content, clarity, and charisma, or in short, whoever you think was bestest on the night. I'll give you a minute now. You can also vote during the next bit, which is a little bonus bit of entertainment and engagement from a science showman, science storyteller, science presenter, Greg Foote. Just before we get to kind of just check generally, are you kind of having success out there? Can we make affirmative grunts? That's great, that's good. So many of you are going to know Greg from his many TV shows and podcasts, his answers to science questions on YouTube, which have clocked up over 20 million views. And tonight, while the judges deliberate, while you get a few extra minutes to cast your vote, Greg has kindly agreed to come out to play. So, can we have a huge, approximately 328 million nanometer welcome to Greg Foote?
Thank you. Hello, hello. Have we had a great night? Yeah, I've been sat at the back. The talks have been absolutely amazing. So my name's Greg Foote. What I want to do tonight is I want to combine my love of finding out how stuff works with retro games. If anyone's up for that. Couple of cheers. Good. I thought this crowd would be. So, first things first, a puzzle. I'm going to do a puzzle to get your brain thinking. Then I'm going to do the second part. It's going to be a game that, if it works, should be a lot of fun and a bit of a giggle. The puzzle, if you've seen this before, I ask that you don't yell out what it's all about and don't tell the person next to you in kind of like some smug way of like, hey, I get this. Let them kind of discover it. Because I do promise that I will give you a little twist on it at the end that you probably won't have seen before. So this is the puzzle, and it's quite simple, really. Let me switch to my camera. What I want you to do is just work out what's in the bottle. So this is kind of an audience interactive moment. What's in the bottle? Some beads, good, right. What color are the beads? Good, you are still awake, white and blue. Are they the same beads? No, how do we know that? Because one's sinking and one's floating. Okay, good. So what can you tell me about the blue beads compared to the white beads? What did I say? Now, first of all, I did hear someone go, one's heavier, which actually in this sense is kind of right, but you have to think about the volume as well as the mass, right? So if you think about a ship and an anchor is a lot lighter than a ship, but the anchor is the one that sinks. So it's about how much space something's taken up, the volume. And that relationship between mass and volume is called density. So what we can say is that when something floats, it's less dense than the liquid that it is floating in. So the white beads are less dense than the liquid that they're floating in. The blue beads are more dense than the liquid they're floating in. Okay, that's stage number one. Because if you look now, something weird is starting to happen. Something slightly counterintuitive is going on. And my question to you is this: what? What is happening? So I want you to come up with a theory. Okay, again, I say, if you have seen this before, keep it to yourself for now. Come up with a theory. Let your neighbor come up with a theory. Yell it out. Any ideas? Any? Someone say magic. Good, thank you very much. I'll take that, I'm done. So I do this a lot with kids because it's a really great way to get them thinking. So some people say maybe it's magnets, maybe there's some sort of attractive force between the beads. The other theory is maybe there's like some heat or something being generated in the platform. That's actually just a box covered in a black cloth. The best idea I've heard, and I love this one, this was a 7-year-old that said this to me last week. They said, well, surely the blue ones are just losing something into the liquid and the white ones are absorbing it. And that increases the mass of the white ones, increases the density, so they start sinking down. The blue ones lose something and they come back up, which I think is a wonderful idea. But does anyone have another idea? Oh, 2 liquids. Okay, let's run with that theory. So if there are 2 liquids in there right now, what do we have to change our explanation for the white beads and the blue beads? So we'd now need to say that the white beads are less dense than the density of the mix of the liquids, right? And the blue beads are more dense than the density of the mix of the liquids. So that kind of works. And then you see them start to come together, and the reason is that the denser liquid is kind of sinking through the gaps in the beads down to the bottom, and the less dense liquid is going to the top. And these white beads are more dense than the less dense liquid, so they start to sink down. And these blue beads are less dense than the more dense liquid, so they start to come up, and eventually they find equilibrium in the middle. And that is exactly what the explanation is. Any idea what the 2 liquids are? Because we've got a clever crowd. No? They need to be able to mix. Not oil and water. Gin and tonic, I wish, mate. I wish. Share that around. So one of them is alcoholic. So isopropyl alcohol on the top is the least dense, and a really saturated salt solution at the bottom. Now, you can just go online and you can buy this, right? As I've seen it on American Teachers Resources website. You can buy this kit, you can mix it up, they give you the beads. But I like to play with stuff. So what I did was I sieved out the beads, and I went around and tried loads of different bits of plastic, and I was like, which type of plastic do I actually need to make this work? Now, what you actually find is that, as someone out there, some clever clogs yelled out, it's polyethylene on the top. It can be low or high density. The one at the bottom is polystyrene or ABS, at which point my brain went, hang on a minute, isn't that the same material that Lego's made of? So I thought, can I recreate this bottle with Lego? So I gave it a go. This took a lot of playing. This is the first time I've shown anyone this. And this is my bottle full of Lego. So what I've got is a whole bunch of different pieces of Lego in there. And I want you to try to work out what on earth is going on. So have a look at the combinations of the pieces of combinations of the pieces of Lego, and try to figure out why is it doing what it's doing. Because some have sunk, and some have floated. But they're all made of Lego, right? So they're all made of ABS, and the ABS previously was the same as the blue beads, right? So it sunk previously, and then it started floating back up again. What Nick and I are doing are attempting to set up the second demo, which, setting this up live, is very risky, but we're going to give it a go, because why not go big or go home? I'm going to come back to the Lego one. I will explain that one to you later, because what I want to do now, just keep going, buddy. Let's see if we can make it work. What I want to do now is show you the second part of this, which is a game. Now, first things first, I've got a question for you. I said I like to work out how stuff works, right? So my question to you is, how does the keyboard on your laptop work? Now, I wanted to find out the answer to this. So what I did was I took an old keyboard. Now, I get to work on Blue Peter, which is an absolute dream come true. I get to do science items on Blue Peter for the last 4 or 5 years with the guys. So I have to say, here's one I made earlier. Although technically, here's one I broke earlier, as you'll see. But you can see there's a Windows symbol down the bottom corner, so it's useless, right? I mean, what are you going to use that for anyway? It doesn't really matter. So I took a screwdriver to it and started popping off the normal buttons, and you can see they're held on with a little hinge. So they just hinge on like that, and when you press on top, you press the hinge, and it pushes the plastic down on top of that thing, which we'll call a nipple, for want of a better phrase. Ouch. But the thing is, when you press down on top of that nipple, what you're doing is you're pushing a bit of metal down, and then if you look at the back, there's a circuit board and it completes a circuit. So for every button that you press on there, it completes a circuit, allows the electricity to flow on one specific circuit to the CPU, the central processing unit, and it goes, all right, you've just pressed spacebar, or you've just pressed A, or whatever. Now, if you plug another keyboard into it, an external keyboard, that just acts as a surrogate. So that's just another set of keys, essentially. But the thing is, you don't need to use keys. You can use anything that can form a switch. So who's played with a makey-makey before? Oh, you're going to so want to if you haven't played with one of these before. So this is a makey-makey attached to some mushrooms. Now, this here is the makey-makey. It's a simple circuit board. And what you've got is, like the old school controllers, up, down, left, right, space, and click. Now, this is exactly like what happens when you press the keys on your keyboard. So what you need to do is you need to connect, say, the up to the earth, which is down the bottom here, and that will send a signal back via USB to your laptop and say, you've just pressed up. What I could do is I could just, let's think about what's happening. Electricity's coming along the wire, coming through the makey-makey. It's now on top of these 4 mushrooms. If I was to connect this mushroom to Earth, that would complete the circuit and you'd get the up symbol sent. And the mushrooms are made of water, so they conduct electricity. I could use a wire to do that, or I could use something else that contains a lot of water and conducts electricity, like me. So I'm going to try to control this, make a bunch of circuits, and what I'm going to do as part of it is I'm going to play Mario. So I had fun with this. Okay, are you ready? Let's go. So, yeah. Now this is tricky because I've got to go up and right. Nice. So Mario, everyone's favourite. Thank you very much. I got him right here. Mario is everyone's favourite Italian plumber, designed by a Japanese designer. It's very hard to talk at the same time. First came out in 1981 in Donkey Kong, which is essentially just a love triangle between Mario, his girlfriend, and a gorilla. Yes, come on. Then he joined up with his brother in 83, and then we got this, Super Mario Bros. In 85. Oh, we are not playing another level. But I think I haven't had the thumbs up yet, which means I've got enough time to have a quick game. To play this game, which is essentially this, but supersized into human level, I need 4 people who are willing to come on stage and take off their shoes and socks. Because you need to be barefoot, because we need to conduct the electricity. So can we get one of the 2 people over there? You can kind of play paper, scissors, stone to decide who. Yes, this lady here, come on up. Do we have anyone from at the back? Who's just waved? Yes, person who's, sorry, it's the lady behind you was waving even stronger. So that's you. Come on up, slip off your shoes and socks. That's 3. I need one more. Yeah, one of you 2. You decide between yourselves, battle it out, fight it out. One of you come up. Right, shoes and socks off. Let's see if I can get this to work. So I'm going to switch over to the other camera. If you can all take your shoes and socks off, that'd be wonderful. Let's flip this the other way. Now, we have no idea if this is going to work, guys, because this is a really bonkers idea that I came up with. So what we're going to do is on the floor there, it's going to be really hard for you to see because there's a table in the way. Oh, you can kind of see it. On the floor, I've remade the makey-makey. Thank you, Nick, for doing this, as per my crazy ideas. We've got the 2 earth lines at the side. So what you're going to need to do, we're going to have 2 on one side, 2 on the other side. You're going to have 1 foot on the earth line, and then your other foot is going to play the pad, like this. Okay, so that's the theory. Let's see if I can set up this Pong, and hopefully, right. So this is now working. So fingers crossed. Touch some of the pads. So that's it. So hopefully you should be the down on this side. You should be the up on this side. You should be the up on that side, down on that side. So just try pressing the pad with 1 foot. That's it. And that's move that up. Oh my goodness, is it working? And then let go with your foot and you do that one. That comes down. Right, so we're working on this side. You try this side. We're going up. And put your back foot on that one there and let go. All right, are you ready for a game? So everyone, just take your foot off the middle pads for now. We're going to reset this. And we're going to play Pong. Right, you're off. Work with your team. Down on that. That's it. That's it. And it's going to speed up. Now you need to root for your audience. So this side is this half over this side. I need to hear some noise. Yell up and down. This side over here, rooting for those two over there. Good skills. It's going to speed up. You know what happens with Pong? You guys are good. Has it stopped working? That's it. Yeah, you've got to take your foot off. That's it. That's cool. So whenever you want it to go up, make sure the other person has the foot. That's it. 3-all at the moment. So I was going to say go to 5, but basically this is the time filler. So we're going to 12. We're not actually going to 12. They've now had their obligatory 15 minutes. So we're going to see how much longer they take. How are we doing? So this team need to pull it back out of the bag. Push up. Oh! Oh! Okay, ready? Up on that side. Beautiful. I remember playing this as a kid. This is one of the first ever games that I played. Down, down! See, now you've just got professional. Now I need to go back into it and turn up the speed a bit. Oh, that was close. Oh! Ladies and gentlemen, this team here win 5-4. Give them a huge round of applause. Our champions. Good work. Thank you so much. You guys were great as well. It was very close. Give these a huge round of applause. Thank you so, so much. Oh, that was utterly bonkers. I can't actually believe that worked, mate. I'm very happy about that. Right, so just while the judges are finishing off, let me just explain the Lego to you. So let's get the Lego going again. So do we have some theories out there? Awesome. So can we hear it? Thanks very much. Goodbye. Yeah, I'm going to repeat that and sound really knowledgeable, but basically it's exactly what you said. So these are the variety of combinations that you can have in there. So I've put in a bunch of kind of separate plates, and then as the gentleman said, there's different combinations. So you can have a block with a plate on the bottom, or a block with the plate on the top, or the same with the mini blocks as well. So what you find is that as per the previous ABS, when there's just a single chunk of it, it sinks down to the bottom. Then when the mixtures start separating, it starts coming up because it is less dense than that saturated salt solution. What's interesting is what's happening at the top. So any two pieces that have been locked together in this orientation, like this, with a block on the bottom, they've trapped all the air in that piece above. So now they're much, much more buoyant. In fact, they're too buoyant to start to sink at all. And it's the ones that have the piece on the top, like this, that still trap a little bit of air and just the right amount of air for that perfect buoyancy balancing act, that they stay on the top and then slowly start to sink. What I really started to have fun was chucking different Lego pieces in there. Because that's when I was like, oh, I'll have the Rocket Man, because that's kind of sciencey, and some were sinking and some were floating. So you can try these, and what I'm going to do is I'm going to tweet a link, because I found that on the American website, just bought the kit, played with it, sieved out the beads. Then when I found about the Lego, I started playing, because that's all science is, right? It's just playing and coming up with ideas. So I was trying different combinations. I was getting so frustrated. So I said, hey, Twitter, you know what you do. Hey, Twitter, what the heck is going on here? And somebody went, I wrote a paper about that. This guy's amazing. He's called Tom Kunzelman, and he is in America, and I will tweet a link to his paper afterwards so you can go and play with all this. He's added in the Lego stuff as well now as well. So I'm at Greg Foot on Twitter. Any comments or ideas, send them over and give it a go, because it was a lot of fun. Thank you very, very much. It looks like we've got a solution and an answer. Thank you, guys.
Big round, big round. Genius to play Pong with feet. Foot Pong that you actually like for once is brilliant as well. So that is Greg Foot. Seek him out online, seek him out on Blue Peter, seek him out wherever you wish to as well. And we want to do some proper thank you. So as you saw from the subtly done thumbs up sign. The judges have finished their ruminations, their calculations. They are ready to show their workings. So before the big reveal, can we get the judges back on stage as their chairs magically appear, please? Viv Parry, Clifford Johnson, and Farah Nazir. They're coming very slowly. And just because we can, and because it adds drama, and the stage is just about big enough, can we all get all 12 International Famelab finalists back up as well? So first our Bangladesh champion, Alvi Islam. From Nicosia and over here for Tini Kalampalika. UK champion, Lucy Guile. Our Spaniard in the works, Juan Magalef. Our Qatar cutter winner, Wad Al Khair. Amazing Malaysian, Kai Mohammed Hanifaya. Wales of Oz, Vanessa Perrotta. Gal from Portugal, Barbara Pinho. The German winner, who's really a Turk, Veli Buruluzlu. The Swiss champ, who's really a Ruski, Dimitri Kopiansky. Our winner from Hungary, Agnes Kistov. And Romanian champion, Nichna Ioan Nicolescu. And I like the way you formed a kind of Famelab Berlin Wall, blocking off the judges into a small. It takes a lot to keep Viv Parry locked up. She's going to burst through any second now. Wait till you're summoned. It's coming. It's coming. It's coming. It's coming. Now, finally, if there's any room on the stage, we're also going to get two people to help give out the prizes. One you met right at the start. We're going to get it back again now. Please welcome the Director of Education at Cheltenham Festivals, Ali Maul. Just everybody else gets the real rocky music, but you get the banjo. I have no idea what the symbolism is there. And the other one, someone who helps maintain the vitality and longevity of Famelab right around the world, British Council Science Advisor and Head of Famelab, effectively, Adrian Fenton. So we'll start with the one prize that we can all agree is correct, is democratic, deserved, a crowd pleaser. It is the audience vote winner that you voted for. So to announce who it is and hand over their award, this beautiful special made award, I believe, Ali, you have got a microphone, and more importantly, you have got an envelope.
I have got an envelope in front of me. And the winner, the audience winner, is... It's Mikna from Romania.
Yeah. Well done. Well deserved. I think we can safely say the majority of people here and also, of course, watching online, who also got to vote if they wanted to as well. So we'll agree with that being the winner. Now we get to the slightly more contentious business of what our three judges have decided. So as you saw, it was an impossible task. They slightly sprawled in terms of time, although I thought Greg filled brilliantly. Tell us about, clearly, it was not easy.
It wasn't. It really genuinely wasn't. So let us give you some thoughts. And I'm going to go through them in order, very briefly.
This is not order of winning or anything like that. It's just order,
No,
right?
just the order they came. Alvi, where's Alvi? Alvi,
I think they've tried to stay in order as best they can.
Alvi, we loved your songs, and it brought such a lot to your presentation. You, with your synesthesia for Tini, well, we saw you in full colour. It was lovely. We enjoyed it enormously. Lucy, we know you are going to be a great doctor with those fabulous communication skills. Well done. Juan, you had a really challenging subject. We thought you explained it very well. You were utterly engaging. We loved you.
Farah, we thought you were a great judge. Oh, no, you just sat in the row there. Fine, yeah.
Wild with your stem cells. And what we really liked about your presentation was that you brought the everyday to stem cells, not just the really, cutting-edge medical uses, but actually the things that people probably will use them for very soon. Siti, we thought you had this very clear way of presenting, and some very good content. Vanessa, how could we not adore your snot? And what a lovely bit of storytelling you gave us. Barbara, GFP and cancer cells, you showed us the light, we followed it. Thank you. Then we had Veli, who gave us, I thought, the best joke of the night, virus exit. Top joke. Dimitri, not from Switzerland. Oh, have I missed somebody out? Veli. No, sorry, it was Veli, yes. Switzerland, Dimitri with your parasites. It was a great bit of storytelling, and we think your cat is fab. And I think you should bring her along. Agnes, I think you had the best analogy of the night with your baby. I think that was, I'd never heard that analogy before. I thought it was a really good one, and I know the other judges did too. And finally, your regenerative dentistry, well, you've heard already what the audience think of you. You're obviously fabulous. So,
collective round of applause, I think, at this point, call for. So this is where we have to move from the lovely, in a way, you're all winners, to the slightly more concrete, but in fact, only one of you plus 2 runners-up will be.
Who do you want first?
I think traditionally we should have two. It's very hard to do the 2 joint runners-up equally because they're both equal, but you have to say the names sequentially due to the linear nature of time.
So, we have, first of all, with her whale snot, Vanessa.
And Adrian will present.
And secondly, but not
equally.
secondly, equally, with his good viruses, it's Veli.
There's nowhere to go but the end.
So, as for a winner, I think one of the most important things that you can do is hold people with authority. And in science storytelling, actually a moment of calm and really fine content can be incredibly effective at communicating science. And we thought that the person who did that better than anybody else, she now looks for the name, no, I know the name, I just can't find the
no one's
full.
noticed, keep going, keep going.
It's City. I was looking at all of you, and while she spoke, you could have heard a pin drop in this audience. I think you probably have the smallest voice, and you may even be the littlest, but actually the presence on stage was the thing that actually made us think that you are a really great science communicator, and your content was fabulous.
Thank you so much.
I'm going to hand you a microphone.
This is working.
Oh, yeah, it's still probably on, but just in case, to make it easy from them. Okay, it's very short because we're very late, but first of all, congratulations. Secondly,
you,
any
Quentin.
thoughts from you about this unparalleled honour?
It's really way past my bedtime, to be honest.
It's past their bedtime as well, but they've stayed up for you.
What was the question again?
It was something about, like, the winning Famelab thing. It's probably old news to you now, but...
I think you
would
could
it be first, would lost for words be a
It
phrase that
lost for
comes to
words.
mind?
Are you changing your mind? Yeah, I'm pretty shell-shocked right now.
And maybe a little word for your fallen comrades?
No, I thought everybody was amazing and it could have gone to anyone. So that's why I'm so shell-shocked. So really congratulations to everyone for really doing justice to your content. And
Your new Famelab champion, Kai Mohammed Hanifa. That's it, ladies and gentlemen. Thank you for coming. Kai deserves to be a winner. The others do not deserve to be losers, but they're not. They are now and forever Famelabbers. And for particularly international famous. So thanks to them, thanks to our judges, thanks to Greg Foote, thanks to the backstage team, thanks to the Famelab organisers, particularly here at Cheltenham, Farha Bakawala. Thanks to yourselves for coming along. Sorry we've been a bit longer than we meant to be, but I hope you think it was all added value. Congratulations again to our newly crowned Famelab International Champion, Kai Mohammed Hanifa.